How we doing today, guys? This is Mr. Novak. Today we're going to be looking at gravitational potential energy and kind of dealing with kind of the mathematical application of that. So we've kind of been introduced already with the types of energy. We've kind of gone through kinetic energy. We've gone through potential energy as well, and we've gone into different types with elastic and gravitational potential (GPE). So today we're going to kind of be dealing with like the math formulas dealing with gravitational potential energy. We've kind of done some examples with this already. Now we're doing the math application. So if we take a look at this picture, we have a rock and it's on the edge of a cliff. So as we've kind of gone over already, this has a lot of gravitational potential energy because of its height from the ground. And what we want to do today is kind of find out how to calculate that from a mathematical perspective. All right, so quickly we'll kind of take a look at our notes real quick. So gravitational potential energy is potential energy related to an object's height is called gravitational potential energy. So this is something we've already covered, but just a kind of refresher of the definition. The formula for gravitational potential energy, or GPE, is what I'll call it as a shorthand way, is mass times gravity times height. So it'll also be represented as GPE equals m times g times h. Okay. So the real important thing to kind of know here is when we're dealing with gravity, we'll mostly be dealing with problems that are dealing with on Earth, because the problems that we would have to calculate as a scientist are going to be dealing with problems that are on Earth for the most part. So gravity is always going to be represented on Earth by 9.8 meters per second per second. So that again goes towards the acceleration on Earth, and that tells you how fast something travels. So it will increase its speed at a rate of 9.8 meters per second per second. So every second it will increase its speed by 9.8 meters per second. So that's just a little background to kind of to help you understand that. That's why we're using that number, because we're dealing with problems around Earth. And gravity on Earth is 9.8 meters per second. So as long as we got that. And our last part is unit for energy is a joule. We've kind of gone over that already with, we've been talking about work and power and things like that. And this is just another unit that we're going to continue to use is the joule. We've kind of talked about that already. All right, so let's take a look here. So we have up top here, I just put up the constant for gravity, which was 9.8 meters per second, and I also put up the formula just so we can have that to look at to help us solve the problems. So let's take a look at this problem. So a 3-kilogram ball falls from 8 meters, and it says, how much is the ball's GPE, or gravitational potential energy? So what we want to look at is we want to plug in what we know. So I know my mass, okay, dealing with the ball is 3 kilograms. So I'll put 3 kg. My distance, right, or my height is 8 meters, so I'm going to fill that in. And again, like I said, it's not written in the problem, but I know this is a constant, right? With gravity, my gravity is going to be 9.8 meters per second. Okay? So I'm going to write my formula. So I have GPE equals m times g times h. And I plug it in. So I have 3 times 9.8 times 8. I put that in the calculator, and that will give me a total of 235.2 joules. So I'm going to put a J for joules just as a refresher. So our GPE equals this. So that's our answer, right? Pretty straightforward way of going about to solve this problem. Okay. So I'm going to give you one more example here, and this one it'll be a little bit different in terms of what it's asking for us to do. So this one will just be a little bit different. So let's take a look. Okay, so again, I have my gravity and I have my GPE at the top, just as a reference. So a 24 kilogram toy falls from 4 meters to 2 meters. How much does the toy's GPE change? So this one is a little bit different. So it's asking us for what the GPE is, what the change in GPE. So what we need to do is we need to find out what that height is, right, from when it goes from 4 to 2. So what I have to do on this one is I have to find the difference between these two. So I have to subtract this number and I have to subtract this number as well. So I'm going to find this to find out how much of the height that it actually fell. And it makes sense. So if I know it started at a height of 4 and then it falls to a height of 2 meters. So I do 4 minus 2, and it's going to equal 2 meters. So that's my distance, or that's my height, I should say. All right, that's the height now, because that's how far it traveled. So that's what it's calculating. Like how far did it travel? So it's going at a height of 2 meters. So I'm going to fill that in over here. So that's 2 meters. Let's fill in the rest of our problem. So a 24 kilogram toy is my mass, so I put 24 kg, and again my gravity is 9.8 meters per second, right? Always deals with Earth, it'll always be 9.8 meters per second. So then we'll plug it in. So if I do GPE equals m times g times h, my mass is 24, my gravity is 9.8 times 9.8, and times 2. So I plug that into my handy dandy calculator, and I get a total of 470.4 joules, and I'll put my GPE equals, and that's my answer, right? Put my little J there, make it look a little bit nicer. And that's basically it. So when you're trying to solve these problems, the first part is if it just gives you a height or a height from where it falls from, you have to calculate it and just solve. If some problems might be giving you something where it started at this height and ended at this height, so you guys have to find the difference. So you have to subtract it to figure out what your height is to use in the problem, and then it's just straight like the other one. It's pretty straightforward. That's really it. Again, if you guys need help, let me know. You guys are working on your check for understanding after this, and as well as a worksheet. Again, if you need help or any questions, please let me know. Once again, this is Mr. Novak signing off. Have a great day.